Ciao friends, and welcome to a new Unplugged video from SQL BI. In this video, I want to work with you on a measure that I received to optimize. So, a customer sent me a file that does not contain sensitive data, so we can use it to play together. And there is a measure that is slow. As we always do with Unplugged videos, the goal is not to show you specific optimization techniques, but rather looking at the entire process of optimizing a measure. So with no further ado, let's get started by looking at the model, the measure, and then we start working on it together. This is the file that I received. It contains a very simple data model with orders, vendors, data, and then a measure table that only contains the measures. And that is the report. The claim is that the report is slow, so we need to check it. And the first thing that we need to do is understand what is the measure that is slow. I already know because I checked that fragmented purchase order is the slow measure. But we need to get a first indication about what it means slow. So let's launch Performance Analyzer. We start recording, refresh the visual to get a first idea of the speed. And you see that all the visuals are quite fast, except this table that takes 10 seconds to run. And this table is this visual that only contains the vendor number, the vendor name, and the fragmented purchase order. Let me copy the query because we are going to use it later. For now, let's take a look at the fragmented purchase order measure. Here it is. I'm not interested in the semantics of the measure, so in what it computes, but it's grabbing the maximum order date, the minimum order date, then it's using summarize to group orders by date and site vendor, and it also computes the distinct count of order number. So it's computing for each date and vendor the number of orders, and later it's using this table as a filter where the number of orders is greater than 2. So it's retrieving the dates and the sites where there are more than 2 identical orders. And then it's computing the number of those orders, applying a further filter. And it's taking 10 seconds on a model that is not that large. I just look at the size of the file. Let's look at orders. Orders is 40,000 rows, so it's quite small. And taking 10 seconds to scan 40,000 rows is definitely bad. I already copied the query, so let's launch DAX Studio. Where are you, DAX Studio? External Tools, DAX Studio. And we start understanding a bit better the problem. Let me move DAX Studio on a different monitor. Here I can copy the query. Now this is the query that is being executed. Let's make it a bit simpler. We don't need this defined part. The summarize column is here. And we can also get rid of subtotals. We don't need them. So again, it's a bit simpler. It's grouping by orders site ID. No, I messed up something. Yes, I didn't copy, I guess, the correct query. Yeah, I copied the wrong query, so let me do that again. Let's clear everything, refresh. Let's refresh everything so I'm sure that I copy the table. It's going to take around 10 seconds. Copy the query, go there, paste it. Now, this is the right query. It's grouping by vendor number and vendor name. So again, we get rid of things that we are not interested in, and we also get rid of subtotals. So it's grouping by vendor number, vendor name, Okay, let's format it. Now, this is a query I like, grouping by vendor name, and it's computing the fragmented purchase order. Let's enable server timings, and we need the first idea of what is happening here. Let's look at server timings. We know it's going to take around 10 seconds. What we don't know is why that measure that only computes a few distinct count is so slow. And here it is. Look at the number of storage engine CPU queries that is being executed. We have 6 seconds of storage engine CPU, around 3 seconds of formula engine, but the real problem is that we have 2,000 storage engine queries. Each individual query is not that bad. Let me go to a button layout and also get rid of this. So each individual query is not complex. It's also always grouping by order, date, site vendor, and computing a distinct count. It's very fast, 3 milliseconds, 2 milliseconds, but we have the filter, we have 2,000 of them. So let's take a look at the code of the measure, and then we understand where the problem is. We need to search for the measure that is here, fragmented purchase order. Let's define the measure and then get rid of this. And let's throw reason on top of it. Well, the R, first we can make it, I think, a bit simpler, because look at what is happening here. It's gathering the max order date, the min order date, and it's using these two variables to apply a filter on the orders table. And it's also filtering the table that is used in summarize. Now, the filter on order date is actually already active here. So I would guess that this part of the filter is entirely useless. But as always, I'm never sure about that. So let's define this as test. Now, my bet is that we can get rid of these two variables and this filter without changing the measure. But I need to make sure about that, so we can compute, let's call it test, the fragmented purchase order minus my measure, order by test descending. The reason I'm doing this is because if I make any change in test and the result is different than fragmented purchase order, I will immediately see the result. Otherwise, I will see 0 everywhere. That means my change didn't change anything in the code. And now it's a bit simpler. So let's run it. Now, I'm not interested in performance. I'm more interested first in the result. I want to see 0 everywhere. And if that happens, it means that I can get rid of the old measure and just use the new one. Of course, it's taking double the time because now it's computing both test and the other one. But you see, test is always 0, meaning that those two conditions were useless. Now we can just return test because we know the code is correct. And I don't think this improved performance. Let's waste 10 seconds to check. We still have the numbers, and server timing still shows 2,000, 3,000, no, a huge number of storage engine queries. 2,000 storage engine queries. Now, what's the reason for that? We are using summarize to group by order, date, and vendor, and then we are filtering the rows where the number of purchase order is greater or equal than 2. I think the problem is this summarize. Now, if you follow our blog and our articles, you know that using summarize to group by is fine. So summarize up to this point is totally fine. But using summarize to also compute columns is bad. Now, we do have an article that explains the details about summarize. I think it's All the Secrets of Summarize that describes the reason why it is bad. Summarize will do clustering, so it builds clusters of order data and site vendors, but then it applies the filter on all the columns. So I guess that in order to get rid of the problem, we just need to use add columns here and go to a different pattern. We use add columns and we use summarize to do only the grouping by. We compute the purchase order, distinct count. We need to add calculate here, because add column just generates a row context and we need a filter context. So calculate performs context transition. And then we do the distinct count where purchase order greater or equal than 2. Now this should be the same, but I guess it's going to get rid of these 2000 queries. Let's test it. And it does. Now it's 21 milliseconds with only 4 storage engine queries. We need to test that the numbers are still the same. So let me add the check, that is fragmented purchase order minus test. Let's run it. This is going to take 10 seconds because it needs to execute fragmented purchase order. That is going to be slow, but I need to check that the numbers are still correct. And they are. You see, it's 0 everywhere, so it's computing the same number, but it's much faster. Now it runs in 20 milliseconds, and the number of storage engine query is greatly reduced, because there is no longer no need to do the clustering. That is a very common pattern. Whenever you have summarize, and summarize performs both the grouping by part and the calculation of any measure, specifically for distinct count, that is a bad pattern, because summarize will do clustering. Clustering requires multiple scans of the orders table, and even though you have only 44,000 rows, that is gonna take forever. So among the optimization techniques that we teach in the optimizing DAX training, this is probably one of the most effective ones. You go from 10 seconds to 20 milliseconds quite easily. As you have seen, that was an easy one. The process of optimizing code is always the same. You start from a report that is running slow, then you check where the problem is. In this case, it was just one measure. We simplified that a bit because there were some code that was useless, but then the real change was getting rid of summarize to compute columns. Summarize is useful to do grouping by. Never ever use summarize to compute columns. You are in danger of two different problems. First of all, the numbers might be wrong, or let's say unexpected, because summarize performs clustering, and clustering is slow and produces unexpected results. Worse, performance. Performance are really bad, because specifically for non-additive calculations, summarize will require to perform a lot of scans of the tables. We had 2000 storage engine queries that, despite being very fast, there were just too many of them. So following best practices, like in this case, goes from 10 seconds to 20 milliseconds in a quite an easy way. Enjoy DAX!